Scientific Standards in Forensics by Richard Jonathan O. Taduran, Ph.D. In early March, the body of Slovak tourist Michaela Mickova was found in an abandoned chapel in Boracay. The photos that circulated were haunting. A graffitied altar, yellow police tape cutting through vines and debris, and responders removing a body bag along a path scattered with dry leaves. Some wore gloves and masks. None wore full protective gear. These photos were not just distressing, they were revealing. As Ph.D. Chair Popoy Vera said last year, the Philippines faces a forensics crisis, a phrase that points not only to gaps in training or facilities, but also to something deeper, a lack of clear scientific standards. When truth is fragile and public trust is at stake, how do we ensure that forensic work is done with consistency, care, and credibility? The answer is science, not just in the form of technology or advanced lab tests, but science as a way of thinking. At the heart of any credible forensic system are standards, clear, consistent methods that promote care, accountability, and integrity. Why scientific standards matter? Science is not merely a collection of facts. It is a process, a disciplined way to make sense of the unknown. It rests on 8 core characteristics. It is empirical, relying on observable data, systematic, following structured procedures, and objective, minimizing personal bias. It is replicable, so others can verify results. It is testable, meaning its claims can be challenged, tentative, always open to refinement, predictive, helping us anticipate outcomes, and self-correcting, constantly improving when errors are found. Forensic science differs from most scientific fields in one key way. It often operates without access to a definitive truth. At many crime scenes, we may never fully know what happened. Investigators rely on fragments, bloodstains, fingerprints, bone chips, to build a coherent account. In this absence of certainty, how the science is done becomes just as important as what it says. Without clear standards, forensic work can begin to drift into speculation, dressed in scientific language. Each core principle becomes crucial. Empirical thinking requires that we only draw conclusions based on what the evidence supports. Systematic methods ensure that investigations are consistent and repeatable. Objectivity guards against bias. Replicability allows others to reach the same result. Testability opens our findings to scrutiny. Tentativeness reminds us to avoid overconfidence. Predictive tools help reconstruct events, and self-correction ensures the discipline evolves responsibly. The Philippine picture. In an ideal system, all forensic practice would reflect these standards, but in the Philippines, as in many parts of the world, this ideal is challenged by limited resources, uneven training, and institutional constraints. Many crime labs remain underfunded or unaccredited. Caseloads are heavy. Investigators often work under immense pressure, with few tools and little time. Even the most dedicated professionals are stretched thin. But this is why standards matter most, not least. The more constrained the system, the greater the need for structure, consistency, and transparency. Without these, the risk of error increases. Worse, the credibility of forensic work suffers, eroding public trust and damaging the very system it seeks to serve. Scientific standards should not be seen as luxuries reserved for more developed nations. They are safeguards. They do not require perfection, just direction. Even modest changes like consistent documentation practices or basic peer review can significantly improve the reliability of investigations. So, what does a science-based forensic culture in the Philippines look like? First, we need to align our forensic laboratories with internationally recognized standards, such as ISO/IEC 17025:2017, which ensures that lab findings are accurate and reliable. The ISO 21043 series, which deals with forensic processes from the crime scene to the courtroom, offers additional and much-needed structure. Second, the scientific mindset must be embedded across the criminal justice system. not only in forensic science programs, but also in criminology, law enforcement, and legal education. Science is not just content, it is a culture. It teaches us to slow down, ask better questions, and revise conclusions when the evidence demands it. Finally, we need to invest in local forensic research. We need studies that assess error rates, validate common tools and procedures, and test whether global standards can be adapted to our local context. This not only strengthens credibility, it builds capacity and knowledge that is rooted in Philippine realities, a standard for justice. We return, finally, to that image from Boracay, a lifeless body carried from a broken chapel, a team doing its best with what they had. The case of Michaela Mickova is still unfolding. But even in this moment, it reminds us of something essential. In the absence of clear answers, how we search for the truth becomes the story. If we cannot always know what happened, we must at least ensure that the science we use is honest, careful, and worthy of trust. Justice begins long before the courtroom. It begins at the scene, in the lab, and in the standards we choose to uphold. Science does not offer certainty, but it does offer a transparent and structured way to pursue the truth. That is the kind of integrity forensic science must stand for, especially when the truth is unclear and lives are at stake.